folks. We're ready to go. Thank you very much for coming in. I'm here to introduce Reid, who's the... We're here to introduce Reid, who's the CEO of CENSIS, and also Mark Begbie, who's the Business Development Director of CENSIS. I won't bother trying to give you any details because that's why they're here. Essentially, it's one of the first 3 innovation centres funded by the SFC, funded last year initially, and now really very much at its start. So we're very keen to know the status of CENSIS, how we might interact with it, how it operates. Obviously, there are a number of other ICs as well that through MASTS we're quite closely associated with, so we're interested in, are there any parallels, are there any synergies there that we can, I shouldn't use the word exploit, but that's the bottom line. And also really to find out if there are any areas, certainly within St Andrews today, that might be of interest to CENSIS, and certainly whether there are any parallels between the way that we run MASTS and operate MASTS and lessons learned that we might be able to convey to CENSIS as we do with the other ICs as well. So I'll hand you across to Mark. Ian, who will now take you through what CENSIS is and how it operates.
Great. Well, thanks very much for the invite to come here and the opportunity to speak to you. If you hear a disembodied voice, Mark here chipping in to fill in some of the blanks, as I'm sure there will be some blanks. I joined CENSIS about 9 weeks ago now, so I'm still feeling away here, so be gentle with me while I take you through this. So, as the introduction talked about, there's 8 innovation centres in place at the moment. There were a first sort of tranche of 3, and a second tranche of 5, and there will be some more in the future. They're organised in a mixture of sort of technology domains and end application domains. CENSIS is the centre for sensor and imaging systems, so it's a kind of technology domain, I suppose you would say. The innovation centres were set up by the SFC and with SFC money. And they are primarily about bringing about change in economic value add for the exploitation of university research. But there is a little bit of subtext there, and that is that they want to see a culture change in the way industry and universities work together to create commercialisable, industrialisable research and to exploit that and create economic value. So this culture change subtext, it depends what kind of audience you're talking to jump to a conclusion one way or the other. But basically, the way I see it is there needs to be a change in the way both industry and the universities operate and work together. From a university perspective, we can explore that a little bit later on, but it's about trying to shape the research programmes so that there's a fighting chance of industrial relevance on some of the things. It's about operating procedures, it's about responsiveness. From an industrial point of view, I'm sure you'll recognise this, there is a need for, if you like, a more intelligent customer for some of the research output. So if I can take you briefly through this presentation, it's not a long presentation and it's not going to be death by PowerPoint. And if I can take you through this, basically there's kind of 3 blocks, if you like. We're going to talk a little bit about what CENSIS is, who we are, and what we do. Then we're going to look at the current landscape in Scotland for sensor and imaging system technologies. We're going to consider that in the context of markets and sectors, and we're going to talk a little bit about how we're starting to build up a picture of the sector in which you guys work. And we're going to talk a little bit about the technical approach and a lasting legacy of tools to help build an ecosystem, and I mean ecosystem in the industrial innovation sense of the word, which will basically create a platform, I hope, for continued creation of economic value. We just touched in the end on a couple of example studies of projects that we've already done. So if we look at an introduction into the what and the how, if you like, CENSIS, as I said, is about creating economic growth. The main of interest is sensor and imaging technologies, and the levers we have to pull are primarily around that interface between universities and industry. A key part of what we're doing is about outreach, and that is outreach into the industrial base so that we can understand industry problems, and we can phrase the challenges in a way that they can then be mapped onto universities and academic research. Building partnerships amongst the industry suppliers up and down the hierarchy of the supply chain, and also across supply chains, where we can share solutions in one industry that are appropriate in another industry. And basically that's all part of the toolkit for building the innovation that I talked about. One of the things that we are looking at, as I said, is this subtext, the relationship between higher education institutes and industry, and how best they can work together to improve basically the ease with which industry can reach back and pick up academic research output and effectively and efficiently apply it to real-world industrial problems. The flip side of that is how industry can phrase and basically construct the challenge around what the industry faces long term, so it can help provide the universities with an understanding of where their future research might interface and intersect with industrial activity, help shape research interests, and help build cases for you in terms of demonstrating impact, economic impact. So some of the more prosaic tools that we have for doing this are basically collaborative R&D projects, in which case we would work with the industrial partners and with the university partners. We have some grant money earmarked to fund the university element of that research, and we can work with other funders to help fund the industrial side of that. I'm thinking about Scottish Enterprise, Highlands and Islands Enterprise, and also the TSB, the Technology Strategy Board, on a UK-wide perspective. We also have our in-house teams that we can support. Now, the truth of the matter is that's a longer-term aspiration. In reality, we're just now starting to build up our engineering base. We're not going to duplicate what's in the academic research base. What we're doing there is to provide a bit of the glue between lower TRL stuffs coming out of universities and higher TRL stuff where industry feels comfortable with reaching back to. So the kind of resource we're going to have in-house are people who've done design for production, design for manufacture, new product development, new product introduction, supply chain management, those kind of skills that are particularly in short supply in the SME base. Strategic research projects, these are longer term projects of anything from 2 to 3 years, and this is where, working with industry and the academic base, we found industry challenges that don't map onto existing research themes, and there is a clearly identified gap. We don't expect to find many of those, but where we do find them, we have grant money that's earmarked. It's SFC money originally, but it's earmarked for funding strategic research activities, as I said, anything from 2 to 3 years within the university base to address an industry problem rather than a specific company problem over the longer term. And the other sort of long-term lever, which I believe is very important, is that we have a bunch of tools in the toolbox that are around skills and training. There's secondments, so that's funding secondments either way, from the university research base into an industrial company, or vice versa, an industrial's coming and working in a university lab alongside you guys. But we also operate, sorry, let me choose my words carefully here. We also work with a number of HEIs who are operating courses for us specifically around sensor and imaging systems technologies, with modules about business skills, entrepreneurship, etc. and those are an MSc course, an NGD course, and we also fund a couple of courses on a pre-existing, we also fund a couple of studentships on a pre-existing CDT school. And basically our role in that is nothing to do with the delivery of the course or academic excellence. That's completely the domain of the academics that are involved in running that. But our responsibilities are to provide industrial input into the design of the course originally, and to ensure industrial relevance as we go through by tracking back into the industrial base and saying, does this course work for you? How can we change the shape of it so that it would better fit your needs going forward? Right, next slide that we're going to look at. Let me just paint a picture of the current landscape. Why are we interested in sensor and imaging systems? What's so exciting about it? Well, as a global market, it's estimated to be around about, well, comfortably over $500 billion now, and growing to $600 billion in a year's time. Its growth rate for these sensor-based industrial solutions is round about 10% per year, which is very healthy. It's interesting, though, that if you look inside and say, for example, take a technology slice through that market analysis, you see, for example, that wireless-based sensors, wireless technology sensors, are growing at upwards of 40% per annum. And if you take, and this will be of more interest to you, I guess, if you take a vertical slice through it and look at the subsea sector, so that's oil and gas, offshore renewables, offshore infrastructure and construction, a burgeoning field of offshore mineral extraction, then basically, and preservation, environmental systems, aquaculture, etc., then that's an end application that's growing at 40% as well. So that's a very exciting area. If you look at the companies involved with the development of sensor systems in Scotland, that's about £2.5 billion. And that doesn't take into account the economic impact of how those sensors fit into, say, for example, the oil and gas industry, where they're actually underpinning really quite substantial economic value. So this is just companies that are involved in building sensor systems and doing the value-added services on top of sensors. The interesting thing about that market, though, is there's about 140 companies active in it, employing some 10,000 people. So it's important to the Scottish economy from that point of view. The challenge for an organisation like us, CENSIS, in trying to work with that is that there's a handful of companies, probably about 5 or 6, which account for 22% of the value of that 2.5 billion. The rest is spread across really quite small organisations, a wide, diverse spread of organisations involved in a diverse range of technologies. So that presents a huge challenge for an organisation like us in interfacing with them. And that's why the relationship we have with people like you, who've already got established links and understand your sectors very well, is very important to our success as well as yours. Clearly in Scotland, we pride ourselves in having, for the size of the economy and the size of population, a disproportionately strong academic research base. We have broad-based research-intensive universities with a very good educational base. In the particular area of sensors and imaging systems, between industry and academia, some £50 million was spent last year on research, which you would say would be applicable to that sector. The frightening thing is that only about 2% of that actually meets industry requirement and got taken through to industrialization and commercialization. And that's why getting that, and by the way, it's falling, and that's why getting that coupling between the higher education base and universities is so critical for the economic success going forward. So, and you guys will probably fall about laughing at this one because it's a very sort of pedestrian first attempt by us to start getting our hands around the sort of structure for the sectors in which you're interested in. And typically how we approach that is we look at the key underpinning technologies, and our list so far is ultrasonics, wider sonar systems, various scanning technologies, robotic vehicles for underwater construction, monitoring, etc., and inspection. And then the other side of the equation is to start building a picture of the subsectors by end market applications. So we're looking at the broader aquaculture, and then within that maybe fish farming, fisheries, so that's the management of, well, you guys know all this far better than I do. So that, as I said, this is our first attempt to start building a picture of that, and we're looking to you to help us improve our understanding there, both of in terms of the end applications and the key technologies, and the list will be far larger than we've got here. Okay. So one of the challenges we have, and let's look at the right-hand side of this chart for a moment, the CIS as you look at it. So let's look at the CIS stack. So this is basically, how does raw technology get converted into a useful sensor and imaging system capability? So right at the bottom of the stack, and for those of you who are joining us on the webinar, you won't have the benefit of seeing me waving my arms about madly here, but let's have a, oh, there's even a pointer here. So if we look at the bottom of the stack, the sensor element, I mean, basically that's a very broad range of technology. That could be anything from pneumatics through to semiconductors, through to thermocouples, through to pressure gauges. It might include some of the more novel new quantum technologies. The next level up in the stack then, the transductance and pre-processing level, is about how do you get a useful signal out of your fundamental sensor technology, how do you package the sensor, and how do you do any local pre-processing. And then we're talking about things like, you know, drift measurements, we're talking about calibration, etc. Through to the next stage, how you network nodes of sensors together, how they will communicate, through to then taking the data from those sensors and starting the process of converting that into useful information. So that's capturing the data, storing the data, post-processing the data, doing analysis, visualization and representation, etc. So as you can see at the bottom of this, you've got a very wide range of potential technologies at the sensor element level, and at the top of it you've got a whole range of value-added services that you can build on top of this stack that could service a whole range of end market applications. So it's a very challenging space to be working in, and the domain of CENSIS activity is throughout that stack. So we will work with people, and we'll give you some examples later on, right down here at the raw technology end. We'll work with people on the analysis and post-processing, and we'll work with people all the way at the top of the stack in terms of visualization, and indeed helping people build value-added services on top of that. One of the key ways in which we're going to function, so we're now looking at the chart on the left-hand side of the slide as you look at it, is basically a set of 5 lozenges around a central lozenge, and basically this is the hub and spoke model. So this is CENSIS, if you like, as it's currently envisaged. Core team there, very small core team, engineering, very small engineering team, project management capability, business development activity that Mark's team runs. And then around that, a set of spokes, and we agonized a lot about whether these should be by end market or by technology, and they are this sort of technology end applications kind of definition. And the spokes are groups of people who are volunteers, basically, academics and industrialists, who help us reach out into the industrial community and understand the nature of the challenge that industries are facing, reach out into the academic community and identify possible solutions in the solution space and key resources, and basically will help shape projects going forward of various sizes and durations. One of the other things that the spoke model allows us to do, if you recall when I talked about the skills courses, and as I said we have an MSc Eng.D courses, the outreach of the spokes will allow us to continue to market test whether those courses are appropriate and how they need to be modified to maintain industrial relevance going forward. In terms of building the ecosystem, some of the steps that we have to go through, and I've touched on these already so I can go through these quite quickly, is basically we need to understand the landscape. And that means we need to understand the industry landscape. What are the industry-wide problems in the short, medium and long term? Where are the real gaps? We need to understand the potential solution space. So what's going on in the academic research base? What is the art of the possible? What do we foresee as the art of the possible in the near, medium and longer term? We need to help create an environment in which we can promote the industry academic interaction. And look, I'm not going to pretend we're going to come and change the world, because quite frankly you probably know the companies in your sectors who you deal with on a regular basis far better than we will ever do. But there are things that we can do to help in terms of some of that strategic outreach program which I talked about, holding workshops, bringing together people up and down the supply chains, bringing together teams of academics from various institutions with multidisciplinary skills, with teams of industry players, so that we can start really kind of marrying up the capabilities. The key though is that all we do needs to be industry-led, but there is a little bit of greyness here, and that is, you know, I wouldn't be so arrogant as to come along and say, look, we know what you guys need to be doing, because this is what these are the solutions that we need for an economic future. I mean, basically this is an exercise in give and take here, and basically what we would do is to work with you in terms of identifying promising technologies, try and see where those would intersect with industry's challenges, and then try and build programs to exploit that to the maximum. We've talked about the events programs that we can run. They can take various forms. They can be very technical. They can be very industrial focused. They can be interactive workshops. They can be seminars. We're going to run some clinics with the people who've taken ideas, say maybe from an academic institution out through a startup or spin out. So helping people basically really take ideas and build businesses and create economic value from it. And as I said there, I think one of the key things to promoting this cultural change is basically understanding where each other are coming from, and basically the secondment and skills agenda, I think, is very important to that. So just to finish off, I've got a couple of examples to show you of projects that have either been done by CENSIS or started by CENSIS, or CENSIS's predecessor, which is S3C, that some of you may know. And basically here's a project with a company called Optos. Optos are active in the field of retinal scanning for medical diagnostics. They have a scanner system which basically scans 82% of the retina of your typical eye in less than a second. It's a big market. There's ophthalmoscopes are up at about $18 billion worldwide. It's a very important market. They wanted to improve their chances of developing new products for the export market, and they wanted to basically improve performance around those kind of key criteria. And they needed some new technology, and it came in the form of novel spatial light modulation hardware from the University of Glasgow. Interestingly enough, and it's not in this slide pack, we have the follow-up project with Optos, again with the University of Glasgow, but this time from, believe it or not, the Gravitational Waves Group. The Experimental Gravitational Waves Group have an algorithm that actually helps Optos analyze some of the data they get from their production runs. And I think that again highlights a challenge that often, you know, we have a pretty clear idea of where our research and know-how can get applied, and then something like that will happen that kind of, you would have thought that would be the last place we'd look for a near-term industrial application, but lo and behold, there it was. Here's an example of, actually this is really a material science project. It's with Heriot-Watt University, who have a low temperature co-fired ceramic technology. And basically what this project was, Renishaw build or create production lines that use equipment that needed to be aligned optically. Now that, as anybody who's ever done any of that will know, is a pain in the neck, optical alignment. And basically it's not robust, it's you know, prone to dust and all that kind of things. It's a difficult thing to do, it's very vibration sensitive, blah de blah de blah. It's a difficult thing to do. There have been magnetic sensors that allowed alignment, but those traditionally were planar sensors, and so you had to construct several of these to get the sort of 3D axis for doing alignment. This project used the technology from Heriot-Watt, this co-fired ceramic technology, to basically create 3D sensor, magnetic sensor blocks, which allowed the alignment of equipment at Renishaw. Here's another example which may be of more immediate interest. This is AECOM. This is a company that's a very large organization, builds and manages infrastructure. One of the key divisions that they have is actually the management of water systems. Okay, they use hyperspectral imaging, they use a lot of satellite data, etc., etc. One of the big unknowns was that although this has been proven to be very successful in large bodies of open water, deep water, the question they wanted to answer was, can they use their traditional techniques for smaller, narrower waterways and shallower bodies of waterways, river systems, and also urban water systems? And this was about proving that this was something that could indeed be done. And finally, let's just look at GSS, which is a Scottish company. Basically, GSS does gas detection, and it does gas detection. The old technique for doing gas detection was, well, post-dating chemical analysis and canaries, is basically to take a light source, a bulb and a detector, and then to look basically for absorption. Then technology moved on, you've got LEDs now, and you can integrate semiconductor detectors and LED light sources, and they also did a whole lot of novel things in terms of wrapping up the optical path so they can get it quite small. And this project was actually to add a wireless to it, so it's allowed a small, lightweight, low power, wireless enabled sensor technology for gas detection. And in this particular thing they were looking at exhaled gases from the human body as part of a sort of sport medicine activity, and that was done in conjunction with the University of the West of Scotland. So that's basically what I wanted to take you through today, just a kind of introduction to give you a bit of a flavour on CENSIS. And basically I'm ready to take any questions, and so indeed is Mark. Thank you. Mark has just reminded me of something which I've forgotten to do, so I'll do that now before we go into questions. And that is, one of the things that we want to do very quickly is to engage with the existing university business development activities, because the university has a huge amount of resources in business development, and we're not here to compete with that in any form. We're here to work hand in glove with that, so we wanted to reach out to that community. We've got 2 events, and you might say, why did you pick this time of the year to do it? Because it is holiday time, but we've got 2 events, so that we hoped if somebody was on holiday for the first event, they could come to the second. We have one event in Aberdeen, which is on the 12th of August. I remember that because it's my birthday. It's on the 12th of August, and it's from 12 till 5 at Aberdeen University. Oh, Jury's Inn, sorry, in Aberdeen. And it's about engaging the business development community and explaining in a little bit more detail how we can work together, the mechanics of it, and getting feedback from the universities about, no, you need to change this and change that. And this particular event is undersubscribed at the moment. I think the previous event, which is at Sterling, I believe, is pretty much booked up, but this one's undersubscribed. So if you're available that day, or your business development people are, we really welcome you, your presence as that. It's on the website, the CENSIS website, which is there. You can find out, and as Mark said, it's a jury's in. So I hope you'll be able to come, or at least send some people to that. Right, that's it now. So question time. Thanks.
You mentioned that one of your slides that there was a 2%, I can't remember what you called it, overlap or uptake.
Coupling, it's called.
Right, okay.
It's got a proper definition, but don't ask me what it is. But
and that it was declining. I'd be interested to know what other national figures are and whether it's increasing.
Okay.
So what's the context of that?
Actually, I probably was slightly inaccurate with that. I don't know whether it's declining or increasing. Actually, what is declining, and it's not peculiar to Scotland and it's not peculiar to this sector, it happened across the board, is that R&D intensities in the UK are declining, i.e. the amount of, when you add up the size of the economy and basically do the sum, well, how much of that gets spent on research, then R&D intensities were declined in 2013 for the first time in a long while in the UK. So there is a problem there. You're absolutely right. The systematic thing to do now is to start unpicking that and say, yeah, okay, but what is it for this sector in Scotland, and what are the levers we've got to pull and buttons we've got to press to address that. But it is a challenge. That number, though, and as I said, I couldn't give you the exact the proper economic definition of coupling, but if you like, it's a proxy for measuring how well aligned research activities are, and the greater bulk of that is being done in the public sector, how research activities are with industrial need. As an absolute number, 2% doesn't sound particularly good. But as you said, yeah, there's a lot of comparative work that needs to be done there.
Do we know when France or Belgium
well, yes, we do. I couldn't quote them to you now, but yes, those figures are published. The problem with all this economic data, as you'll know about, is that 2013 figure that we just talked about R&D intensity is a year old, and they always, they're always late, and they're always, of course, with all economic data, subject to revisions afterwards. But those figures are available, and I think France and Germany, which is kind of our nearest competitors, is one area to look. The other area, of course, is to look at the Far East, and some of the R&D intensities there are quite frightening when compared with what we do.
Yeah, I don't have the exact the figures as Ian, but Scotland and the UK is in the lower reaches of the Reid table. France, Germany, the US, Japan, these countries typically significantly outstrip us in this coupling.
Sorry, the gentleman in the blue shirt.
Forgive me if I misunderstood what you've actually presented this morning, but as I see it, what you've said is that there's a sort of gap between us as academics and industry, or the industry players that have the technology that is there and wants to be developed, as you put it, improve the economic outlook and overview for the country. And somehow you guys sit in the middle somewhere and make things happen. Is that right?
I always quake when people start off a question by saying I may have misunderstood what you said, which almost certainly means I've mispresented it. But to answer your question, and I will try and answer it, is yeah. I mean, I think basically that's it. Really, is that yeah. Please.
Just actually clarify a bit more. That what I don't get is what you're particular angle on the thing is, because as you've said, it's sensors and imaging systems that you're really, if you'll excuse me, focusing in on.
Yeah.
And what I don't understand is what particular expertise or links to industry that you guys have that make it possible for that to occur.
Right, okay. No, that's absolutely a perfectly legitimate question, right. Yeah, okay. Let me go back to that. We're just going to go back to that present slide. Did you want to talk to this? Why don't you? Come near my microphone, yes.
So essentially what we are set up to do is all about this coupling idea. So what we are there to support is where there are new capabilities within sensing and imaging. And the slide, the stack is important here because we're not just about sensors themselves. A lot of the value and new application capability these days comes in the higher reaches of that stack, where you're looking at the ways that you network sensors or the ways that you can extract information from a number of sensors and visualize and present that. So in technology terms, it's everything from new sensors through to new ways of understanding the work. And understand MASTS is engaged in a project with Abertay, for instance, on 3D visualization. So what we're there to do is where there is economic potential in a technology. So say, to try and boil it down to and talk around a specific example, the work here on monitoring of cetaceans. If there was another commercial opportunity or a company that wanted to take that monitoring technology and had a market for it, and that was perhaps in something slightly different in monitoring shipping or other assets, and there was a gap there in the application of that technology to that market, our technical staff could support that. We can access funding to support that. So it's that gap where the research is often largely completed, but the risk levels or the maturity for a particular application are not sufficiently well developed for industry to say, okay, I can engage there, I can take that, and I can deploy it. Does that?
I'd like to say yes.
But can I add something else which may help a little bit? Well, I hope it does. At a more sort of pragmatic end of the scale, how can we help in this? Why do we think we can help in this? I mean, basically, we had a number of industrial companies and universities involved in basically signing up to the concept of CENSIS at the beginning, and several of those are now part of our advisory board. There are 3 academics on the advisory board. There are SE and SFC representatives on the advisory board. We're waiting for an HIE representative on the board. We have 2 small to medium-sized enterprises represented on the board who've been very successful in innovation. We have John Innes from Celex on the board. And virtually all of us, as we're trying to build up this team in CENSIS, have come from industry. So we all have our own networks. We've all worked with a variety of companies, both large and small. We have access to, for example, the networks that are in place in SE. We have an open relationship with SE, so we can get access to their networks, and we work with their key account teams. So we have very good networks in place at CENSIS. So if you came with an industrial problem, we might look here for part of the solution, but we would also, through the spokes model, maybe have oversight of a piece of technology that existed, say, for example, in Heriot Watt, and which maybe possibly you guys didn't know about, and we could put that together, and then we would know, for example, in our networks, we'd have people who'd be specialists in fast prototyping, maybe. There are facilities that we put in place in Edinburgh, in Edinburgh and Glasgow, for example, on the semiconductor sensor side, so there are real hard facilities that people can actually go and use. And as I said, the team that I'm building up have all come from industry. They've all done innovation and basically built businesses and brought products to market. And we're building a small engineering team that, I said, has specialisms in those areas that SMEs are particularly weak, and we also have project management resource. So we've got some practical tools and experiences to help in that process.
Can I maybe try again with a different example? Another area where we're developing a potential project. Phil Anderson at SAMS is experienced, his group are experienced and capable in aerial surveys using small remotely piloted aircraft. One of the things that they're interested in looking at is algal blooms and algae. There's a Scottish company that's developing hyperspectral imagers. Now at the moment, an airborne hyperspectral imager is about 15 kilograms, so it's going to crush Phil's UAV. They've now got a prototype device that's down to 400 grams all in. So there's a real interest in the company in developing this imager for new applications. Phil is extremely interested in this to look at algae from remotely piloted aircraft. Would we fund a project for the company to develop an imager for Phil to do that and get research output in algal bloom information? No, absolutely not. The other part of it, though, is that in order to achieve that, the company will develop something that addresses a much bigger market. They also need to access additional expertise in the development of the imager to get to where they need to be, which touches on research groups in Glasgow, Strathclyde and Edinburgh. So the wider project here is a company that wants to develop a system that can be flown on small remotely piloted aircraft. They need expertise from the hyperspectral imager community to develop that. Phil has an interest in developing and trialing this device from which he can get research output, and the company ultimately then will develop a device that they can sell globally as the smallest, lightest, highest performance hyperspectral imager on the market and can get economic value from it. Is that a project we'd fund? Absolutely.
Right. You couldn't have picked a better example, because I actually worked with Phil directly in exactly the same application, and so that's a really good example. Still, what is it that you're actually funding?
Right. So we have two roles in that sort of space. One is to help facilitate the building of that consortium. So in part through our activities, they have contributed to the various partners coming together, having the conversations. We can then, through part of Scottish enterprise commitment to the innovation centres, is a higher level of public support from Scottish enterprise for projects that are going through innovation centres. So ultimately that will probably roll out across the whole of the SE portfolio, but at the moment they're supporting the development of innovation centres as these focal points by giving an elevated level of support to the company. That makes it financially viable then for the company to engage in these projects. There's enough public money there to make sense. The third leg to the stool is our technology group that as Ian said, we're
setting up. So where this company, which is an SME, might struggle to directly integrate the technology coming out of the hyperspectral research groups on its own, we can provide engineering resource in there to help take the research output and make it reliable, repeatable, robust, and integrate it into the company's product development. So we can help provide some additional flexible resource in there that's focused on development, not research.
How do you handle IP?
So our starting position, our starter for 10 on IP is that we don't want companies to pay twice, for one. So if a company is paying for an activity, then they should get the benefit from that. And where that's the case, where there's a CENSIS project that companies are involved in, we want to see the commercial partner have the right to exploit the foreground from that project.
But didn't you just say that it was public money that was actually being put in to make the whole thing possible?
So in that collaborative R&D project, the way the funding flows is that from Scottish Enterprise, there is money given to the company, which, yes, absolutely correct, is public money that goes into the company. That money within the company is to provide aid to them, to enable them to engage in the whole project. The funding to the academic partners then comes from the company. So the state aid is going to the company. The fees that then go to the academic partners effectively are commercial funding into those academic bodies.
Okay.
So that's the flow. We're deliberately not being prescriptive from the outset about things like ownership, background, all of these sort of things. All we are saying is we want companies, when they go into these projects, to have confidence that if the outcome is successful and valuable, they will have the ability to exploit that outcome in their space that the project was set up.
Hi.
I'm interested in your definition of what industry is, because certainly here in St Andrews we develop technology, sensor systems, communication systems to relay that data. We also use those systems ourselves to collect data, sometimes under direct contract, for example, from the Scottish Government, to enable them to execute various responsibilities. Other users of our data may well be people like the Met Office in terms of the ocean modelling. So far, what do you class as industry? Our ability. So we would like to see our ability to service these sectors, which you may or may not call industrial, improved. And through your technical, all the things you have at disposal would help us. So what's industry?
Yeah, I think from our point of view in that scenario, the Met Office, the Scottish Government, all of these sort of people are the client base, the customer base. That doesn't matter who they are. They can be public, they can be private, whatever. The place where economic value can accrue is in that entity that is developing and supplying the devices or services to those customers. So it would be that entity in the middle which would be the first point we would look for economic impact. So if that entity in the middle is a public sector research organization, that would probably have a lower impact weighting than if it were an organization that could clearly, a commercial entity, or a spin-out or an arm's length entity, that could clearly have a business plan to develop and expand those service offerings beyond that initial set of customers and services.
Well, maybe that's an interesting discussion we can follow on a little later on, because I think that we have a self-financing research group. It's not an industrial company. It's not registered as such, but it almost serves the same function in some cases. So again, I think this is something we could maybe talk about.
Yeah, I mean,
let's
have that offline discussion. I think,
I think it may apply to other folk as well who have research groups, and who can actually, the research group can actually service the end user, and this research group can grow and grow and grow and provide, jobs and expertise and etc. But just because it's not quote a company, then does that automatically
I think
exclude it from your...
It's subject to discussion, I think, basically. We're not ideological about this. It's really, if we can construct a credible argument about creating economic value, then I'm sure there are grey areas like that. Some grey areas. Oh, sorry, there was one gentleman. You will be next. There was one gentleman up there. But good man.
I actually used to work in a place that was very similar to yourself, as a research engineer. And I was just wondering then, so you facilitate basically the research, if I have an idea for an optical sensor, you can facilitate, and say a company can exploit that.
No, yeah, this got to be industry-led. So, and again, there are grey areas here, but there's one hand, I've got this great idea, and it is a great idea, and I'm not, and maybe there hasn't been the vision out there to see how it could be applied, but our remit is more about an industry or an organization coming to us and saying, look, I have a problem here and I need to solve this to get this product into a new market or to solve this societal challenge or whatever. Help me do that. And then we would look, and maybe your optical sensor was the way to go, and then we could come and help. So it's got to be industry driven.
Your push activity, your first protocol should be University KT office. Okay. And they're about push. We interface to them, and we're about push.
But just generally speaking, I mean, do you support things like, say, Horizon 2020 or other proposals? I mean, for example, you mentioned Frost and Sullivan earlier.
Yep.
They always have these huge numbers for sensor systems. These figures are always quite useful for, if you're looking for commercialization funds and things like that to commercialize research. Do you support that kind of thing as well? If I was to phone you up and say, can you give me figures on the growth of optical sensors and marine sites in the next 20 years?
We haven't got a department, focused on providing data or research, but fine, please ring us up, because if we've got it, I'll share it with you, kind of thing. But Horizon 2020, that's a really interesting thing. As Mark's talked about, Scottish Enterprise has funds that are earmarked to get priority for projects that CENSIS bring them for the industrial side of it. But our remit calls for us building out beyond that and interfacing with TSB, I mentioned, but also helping industrial and academic collaborations to shape projects that would get Horizon 2020 funding. I suspect, though, to be perfectly honest with you, at the moment where we are in our development, we haven't got either the bandwidth or the expertise in-house yet to do that, although many of us have been involved in bids into Europe, etc. But again, what I'd say is, in the first instance, give us a call, because, as I said, based on our experiences, we may be able to help, but we haven't got dedicated resource for that, but that's a place we need to get to. Yeah.
If we have it, we'll share it. If it needs someone to go and find the reports and analyse, and then again, KE office would be one port of call. Scottish Enterprise might be another port of call, particularly if you've got a partner company that you're going into Horizon 2020 with, they can access that. And then Enterprise Europe Network and Scotland Europa, again, have funds, I believe, that can support proposal development in the academic space, so they would support things like meeting potential partners in Europe and obtaining this sort of information. But the primary organisation in Scotland who buys and has these reports is Scottish Enterprise, and they can in some circumstances, provide support in data from them.
Gentleman in the front row.
This goes somewhere toward what Bernie was talking about, but a different slant to it is it's a difficult way to approach this. But for example, right now I'm involved in one of these types of things. It's not CENSIS, it's somebody else. But it seems we're in a situation where we've come up with the idea, we've designed this bit of gear, it's looking very, very promising, it's all great, but we can't get money to develop it further unless we get an SME involved. So now we go to an SME and say, if this is a success, do you want it? They take it and make money from it. Why can't we get the money to just employ someone to build it for us and make us the supplier of it? It seems there's a lot in it for the SME because they're basically getting free development and free labour of someone else with none of the ties. If it all fails, they haven't lost anything. Whereas we carry the can for everything that may potentially go wrong. So why get them? I don't. You know, we've got this great idea, but we can only get money if we give it to someone for free.
Yeah, I mean, there's two levels to answering that, and one is a level which I don't think is appropriate to talk here about, you know, philosophically about it, and we probably have an exchange of views on that. The other answer to give you is that, you know, our remit as it currently is cast is we are industry driven, sort of full stop, you know, so that's kind of one level of answer. But I think, yeah, look, I understand the frustrations there, and I think the argument would run, right? The argument would run, how well equipped would you be? And you might be very well equipped, but I think in general terms, people would ask the question, how well equipped would you be to take that to an end market, an end customer that's ultimately going to, you know, feed this chain in terms of money? You will want to buy the service. How well equipped are you to do that versus the industrial base? And I think that's where the argument would be. But as
SME be more equipped to develop it in the first place if you just give them money directly to them? That would be university.
They don't necessarily have the smarts, but as I said, this is a philosophical argument. You know, we should probably take offline over a beer somewhere or something.
But I think that
I thought that would do it.
he's all right. I'm the one who's driving. The kernel in there is that, and it is worth a conversation with, because that, to a great extent, comes down to the nub of why we're here. What you're experiencing is you've got something, sorry, as I understand it, you've got something that has real potential, and there's this disjoint between that thing that has real potential and the mechanisms for then realising that potential into something that can be made and sold. And
yeah, why can't I sell it?
Well, that's for the conversation later. But that disjoint, I think, is, you know, comes down to another.
Well, yeah, because appeal. I mean, listen.
And I want to listen to that.
I'm Carol Scully from the Knowledge Transfer Centre, and it's quite clear that there are a couple of issues here that would, you know, by having a conversation with us, we can actually help also signpost and direct you, whether it be to CENSIS, other innovation centres, possible funding pots. For example, I'm the Impact Acceleration Account Manager here, so it's actually becoming clear that some of these questions could be, we can actually provide services and support and signpost to actually help you guys as well.
And if you can get yourself to that event in Aberdeen, we can explore those things in a wider forum with your colleagues.
Can we just take one more question, and then we have to draw it to a close?
Sure.
Please, can I intervene very, very quickly? Are you limited entirely to Scottish companies?
No.
No. Any sort of reference to September 11th. I just need to know, because there are some people that are very interested in the research.
No, we're not, but I have to be in a position, at this phase in our development, I have to be in a position where I can construct a credible argument that economic value will accrue in Scotland. Okay. Thank you very much. Thank you, everybody. Nice.
Within MAST, but I'm sure if there are any other questions,
God, that was an hour.